Way to go. Way to go. Way to know these. Who wants to hear a cow joke? Okay, there's less people, so I'll only say one. What do you call a cow with one leg? Steak. All right, should we just start? We good? Awesome. Hey, everybody. My name is Eric Escobar. I am a wireless consultant at SecureWorks. I do all types of pen testing. I think half of this track talk is probably SecureWorks employees, so thanks, everybody, for showing up. This talk, I'm going to talk about not just how to break wireless stuff, not just, things that are vulnerable and exploitable, but how to actually make use of it. And so that's why I'm calling it Void Your Warranty. It's taking, cheap products off the shelf, hacking them, reworking them so that they're actually more useful than when you initially purchased them. And then I also have a fun story after this, too, because my talk got extended by an additional 30 minutes. So we'll talk about another fun way that you can hack things. So the reason that I kind of started thinking about this topic and this track is because when I got started in cybersecurity, I was basically an analyst. I worked as a blue teamer, as a security person for a company. And when I told them, hey, I'm going to go leave and be a pen tester, well, they said, Eric, we always considered you to be a builder and a creator, not a destroyer and a breaker. And I was like, wow, you're really tugging at my heartstrings here. I got a degree in engineering. I like to build things. I don't think of myself as a destroyer and a breaker. And so they're trying to, pull at this and say, no, Eric, you should stay with us, help fix things. Don't just go break things. So that always kind of stuck with me as no, I think at my base, I'm still an engineer. I'm still a creator. Also, there's some weird feedback in here. I can hear myself talk. So if I'm talking a little bit slower than I normally do, that's why. So basically, when I started becoming a pen tester, that's a hacker, right? We get paid to do the really fun things that normally would be illegal. But really, why does it say just sitting on a park bench? That's a Taylor Swift lyric. Did one of you guys mess with my slides? Somebody definitely added a Taylor Swift lyric to my slides, so kudos. Also, that is me out there behind you. That is in the wireless village playing the Taylor Swift song. So if you want to go try and break that and change the playlist, by all means, please do. So going back to what I was talking about before I got Taylor Swifted, you can buy tons of cheap hardware off of eBay, Alibaba, all these sites. All this hardware typically runs on, one of a couple frequencies. Typically, it's going to be around 433.92 megahertz. That number doesn't really matter because I'll show you why in a little bit. But this frequency is used for tons of different things. You can have thermometers, motion sensors, door sensors, outlets. It's because this frequency range, you don't really need any specific license given by the government, right? Anybody can basically broadcast on this as long as it has FCC approval. And so because of that, all of these cheap device manufacturers, they don't want to have to go through, all the rigmarole to get that finality to broadcast on some weird frequency. That's why they use 433, same thing with why you would use 2.4 gigahertz. There's a handful of different frequencies out there, but all that you need to keep in mind is that cheap plastic hardware typically transmits on this if it's wireless. So in this picture right here, you can see a little cheap motion sensor that I brought with me, and then I have some of these little smart outlets where you literally just press the button, and it clicks the outlet on and off. Now, if you were to flip this device over, you can see what's called an FCC ID. This is basically the stamp of approval that the FCC gives to every wireless device that says, hey, you are allowed to transmit within the United States. Now, you're probably wondering, okay, why do I care about this random-looking serial number thing? And the reason why is because if you do anything with RF, it is a hacker's best friend. And because you can take that ID and you can go use it on the FCC website to go pull down user manuals, setup photos, schematics, basically the full breakdown of what is inside of that device. And so sometimes you'll find, chipsets, you'll find, what frequencies they broadcast on. Sometimes they broadcast on multiple frequencies. You'll find that they, use different chips, the way that they're phased potentially, just tons and tons of information. And so without getting into it, you have the amplitude modulation, frequency modulation, and these are basically just ways that signals are carried in the air. For what we're doing, that doesn't matter at all. You don't have to worry about any of that because all the hardware that you're gonna be using, this is like super 101 stuff, you don't have to go down into the theory. You don't have to worry about tuning your software-defined radio because all of this will basically self-tune on this type of frequency. And a lot of these cheap electronics, they use a type of modulation called on-off keying, basically just high signal, low signal, and that represents some zeros and ones that have a signal that is sent with it. And so if you were just interested in hacking this kind of stuff, if you were just like, oh, I just want to do a replay attack, you could easily take something like a PortaPack, which is just a hack RF with a fancy little screen on it, or the everybody's favorite Flipper Zero, right? You could take one of these devices, clone the signal, just read, wait, press the button, and you would see some data come across, and you'd hit save, and then you could just replay that signal over and over and over and over again. Now, if you're in any type of security field, you can probably see the problem there. If you can just listen and then replay over and over and over and over again, then that signal is not secure at all, right? Especially when you think about what some of these things are, like a motion sensor, door open, door close sensor. If you can replay that, then you can just make that sensor trip and think that something is happening when it's actually not, right? So that's not super great. That's not awesome. That's not something that you would, normally want in the security world. And that's why for like my home security system, I make sure that my door sensors and my motion sensors, they don't use something like this. However, if you have some fun home projects that you're just like, hey, I have an idea to try and get something to work, using the cheap electronics that do just send that one signal out over and over and over again, they're great for prototyping and getting like kind of like a working concept up and running. And so like, again, the code that's on here on the screen, just literal one-liners for how you can read and save to a file and then replay that file right back if you're just on a computer. But now people have flippers all the time, so you can just use those as well. So this is where, like, that's the end of like, hey, you could just hack it, right? That would be really awesome. Great, done. But really, when you look at it, hackers are more than just breakers, right? They're more than just destroyers or something. It's like, hey, let's make this more useful, right? Let's take this and do something with it that's like more interesting and more capable than anything that you could potentially buy off the shelf. Plus, then it's customized to you, and then if you've hacked it, if you've built it, and if you know how it works, then you can tailor it to exactly your design and exactly what you want. So there is a GitHub repo, RTL 433, and it takes everything that I just said, all the amplitude modulation, frequency modulation, all of that stuff, and it allows you to plug in a simple little USB card like this into a Raspberry Pi, into your computer, into your whatever, and it basically takes all that information and it spits it out into a nice, really like pretty picture like that. So you can see via command line, like all the different information that pops out, and it has all the major different types of encodings, a bunch of different schemes of devices that are out there. When I was actually running this at home, I just let it run for a couple of minutes, and I was like, whoa, what's that? Hey, that's my fireplace. I can turn my fireplace on and off with this. This is awesome. I could, what could you use that for, right? And then I also found, I was like, as I was barbecuing one night, that, hey, my meat thermometer actually broadcasts on that frequency too, and I can see the temperature of my meat from my laptop. And so it's one of these things, you just let this go and you just think, what else could you possibly do with this? And so it's like, okay, cool. That's great that there's this repo where you can just like read all this information out. And then maybe if you're a Python programmer or Chat GPTer, you could pull that together and say, oh, I'll try and extract some data and then write a script to perform an action. And that's when I found Node-RED. How many of you guys know what Node-RED is? Okay, I found out about this fairly recently. It's pretty awesome. Basically, it's like home automation on steroids. You can install this thing on a Raspberry Pi, any different platforms, cloud platforms, whatever you name it. It's a really lightweight install. But where the game changer is that it's like click and drag like programming. And so you can have all your workflows make sense within something like Node-RED. And one of the plugins that they have is RTL 433. And so what that means is that you can take all the cheap wireless signals, all those cheap wireless devices, your meat thermometer, your, what was the other thing, your fireplace, and you can say, hey, I want to import all of that information into Node-RED now. And so you take all that information, you import it into Node-RED, and you can draw up some crazy diagrams of what's possible. And much to the chagrin of my wife, all of the different random devices that I purchased now monitor pretty much all the temperature sensors everywhere in the house. Because again, they're cheap. They're like $3, off of Alibaba, and you can just take these things and place them anywhere. And now you can do anything you want with the data. And really, this is less of a this is exactly how to do this, and more of the here are the keywords to Google to take and enact in your life. Because you can do some awesome things with them. And what I want to do is probably not at all important to what many of you want to do. For me, I want to see what the temperature of my chicken coop is. You probably don't care what the temperature of my chicken coop is. But with this, you can do pretty much anything customized to you for a fraction of the cost, if there even is a solution that you could buy online or from anywhere. And so if you look at this flow diagram, this is just some random one that I made a while ago. And so you can see that you can collect data from, different wireless sensors. You can log that data. You can write functions with that data. You can log it. You can, Node-RED also has the capability to graph it, have dials, buttons, pretty much everything that you could hope for and imagine. There's some people that have done some crazy stuff with home brewing setups with this, because again, you can log temperature, you can turn motors on and off. This is really just meant to spur that imagination of what can you actually do with this? So just to give you a little bit more of the capability, I just took some screenshots of the different slides. So if you just look at this, it has full MQTT capability, HTTP request, TCP in, out. You have your UDP requests, you can write to files, there's switches, functions that you can write, you can get statuses, debugs, JSON, XML, whatever you want to do, it has this capability, right? And so where we started with this is I bought some janky, Chinese wireless items that normally you would never even hope to purchase and never even want to purchase, because why would you, right? They're not secure, they're not great. But for something, if you know what you're going to do with it and you know the right way to break it apart and kind of mold it, now think of all the capability that this gives you. We went from $2 wireless motion sensor to now you can have it send you a text message through Twilio when somebody's in your driveway. You can't buy something like that off the internet, and now you just made it for a fraction of the cost. So, okay, that was my not just a breaker, right? Part of a builder. But sometimes security is just for fun. So I'm gonna now kind of change gears a little bit and talk about building something that is really not at all practical. It's not practical, it's not necessary. The world doesn't need this, but I needed this. So here's the story about this. I really like laser tag. Anybody else play laser tag here? Okay, that's far too few hands. There needs to be more people that play laser tag. So with laser tag, does anybody know how it works? Just raise a hand. Just what frequency do you use? You got to yell really loud. So that's how the devices typically communicate back, but the way the guns actually work is infrared, like your TV remote, right? And so I haven't played laser tag in a while. I went with my younger cousin, and I was just like, hey, do you guys want to play laser tag? And they're like, oh, sure, my cousin, they want to go play. And then we got destroyed because I guess now when I was a kid, it was just like everybody got the same gun, everybody got the same whatever. But now you can buy upgrades, you can buy level ups, you can buy armor, like all this random stuff. And there's like club nights for laser tag, which is a little insane. So needless to say, when I just roll in thinking that, hey, I'm just going to play a game of laser tag, got destroyed, absolutely destroyed. And I thought, hey, I can find a way around this. I'm a little bit smarter than this. It's just a blinky light. How hard could this be? So like I said, laser tag works on infrared. And so the same way that you hit transmit, you hit the power button on your phone or your flipper or your TV remote, it just transmits an infrared signal. And so when you shoot that out of your gun, it gets received right there on wherever your tagger spot is. And that's how it indicates that, hey, you made a shot. Well, if it's just light that's blinking out of the front of an LED, you could probably clone that, couldn't you? And now with a flipper, you can super easily. So I won't go into like how ultraviolet and infrared work. Basically, if you have a camera that infrared you just can't see with your eyes typically. You might see a little bit of the red, but cameras can pick it up, and there are very cheap LEDs that can emit it and receive it. So basically, if you were to take a picture of this is, I think I actually took this picture, oh, maybe not. But basically, if you take a picture with a camera that doesn't have an infrared filter, you'll actually see the light blink. So if you take a picture with your phone, you might see an infrared light blink when you press your TV remote, shoot your laser gun, you name it. And so that's how these sensors work. They just emit, they go from there, and that's how it indicates you've been tagged. And this is how small these little lights are and how their little receivers are. They're very cheap. And when I say very cheap, I mean like cents per like dozen. I had to buy like 100 of them minimum when I was buying them in bulk. And so now what happens is once you've been tagged, that information gets sent out over, who knows, the fancier ones now get sent out over Wi-Fi. So good luck trying to compromise something like that while you're in the heat of battle of laser tag. Really all I care about is I just want a better gun and I don't want to have to pay for it. So what's nice is infrared is one-way communication, and just about the other type of frequency you're talking about, 433 megahertz, that same code is repeated over and over and over and over again. So there's no rolling code. It's just a replay attack. Because who would be crazy enough to spend a bunch of time building a device just to hack laser tag? Surely nobody would do that, right? Surely nobody would go and use their engineering mind to go do this. So I saw, first, what do you do before you're going to go build something? You look at the state of the art. You see who has done what out there. And somebody built something very similar to what I was thinking of. Basically, this little device is hooked up to a 9-volt battery, and it lets you just repeat over and over and over again the same frequency. Pretty cool, pretty cool. I wanted more, though. I wanted multiple LEDs. I didn't just want to walk in there with a better gun. I wanted to walk in there with a 180-degree claymore that went off every 10 times a second. I wanted high power. I wanted a user interface, and I wanted to do some data logging so that I could see what other guns other people had potentially in the field. Again, this is totally not necessary, but this is what happens. And then thank you to Michael Howard. Oh, look at him. I should have gotten a picture of, he's right there, everybody. Michael Howard. That's a picture in his old car, not his new car. He's probably mad I don't have a picture of him in his new car. Anyways, I do not know electrical engineering, and Michael Howard knows more electrical engineering than I'll ever forget. Is that how the phrase goes? I don't know electrical engineering. Michael Howard does. So he helped me out so I didn't blow myself out or let the magic smoke out. So the design considerations here were to make it concealable, easy to use, ultra bright LEDs, and have a decent amount of power. So I used a Raspberry Pi Zero, super small, a little Wi-Fi board, and I just wanted to run basically a web server and drive the LEDs. So I didn't find just the super cheap LEDs. I found one that did super bright 1 amp pulses, and they did a super wide cone of 20 degrees. Now, when you're playing laser tag, you probably realize that, hey, your gun is only going to shoot and only hit a small target because they are narrow field, and that's how the simulation of laser tag actually should work. Is, hey, you don't want it to just be scatter. You want it to be, hey, like you're actually trying to hit somebody. Whereas this is 20-degree cone. I'm like, okay, cool. 20 degrees is pretty good, but we need to do better. And so that's why I said, okay, I'm going to get 5 of them, overlap them, and again, make it totally unnecessary. So, of course, I wired it all up, 3D printed it all out, and then did a whole bunch of really janky soldering and hot glue to make it all fit. And then I 3D printed a box and an enclosure for it. And so you can see it basically just fits top down. And I was making it so the design of this is so I could hold it underneath the gun. So that way, while I'm playing, it's not like I'm holding a secondary device. It's, I'm holding it right underneath the laser tagger. So it blends in, and it was not printed in red. It was in all black. So then for the power management, I use the Adafruit Power Boost, and basically it just uses the tiny little LiPo battery convert to 5 volt. Super easy. And then to power the LEDs, because they took a lot of power, I used a buck converter to take the voltage down to 1.2 volts and make efficient use of the power, and just that way I could directly connect it to the battery. Now for connectivity, I had a hotspot in my pocket, and I could run all the commands from my phone. So I'll show you the UI here in a second. So this is what it looks like, just like kind of the flat board aspect of it, all the little messy wiring in there. And you can see, again, it gets messier and messier with all the wires in there and all the hot glue. And now, so basically, I am not a web developer. I am not an electrical engineer. So I had a PHP web end. I had no idea what I was doing. This was before ChatGPT. So I took the RxTX pins to basically hook it up to the infrared, and then I had a file that it would basically just read to and write from. So this is horrible, horrible PHP. You should never do this. But hey, I'm the only one connecting to it, so I wasn't that worried about it. Then I used the software called IRPy. Basically what this does is this takes care of me having to understand how infrared actually works, right? I know that there are timing sequences, that there are spaces, that there are, X amount of repetitions. I don't want to learn how any of that works. I just want my laser gun to shoot. So what I did is I just utilized this library and just said, hey, capture the signal, send the signal. It does that. Awesome. So then what I did is I basically just said, okay, here's how I want this to work. If I'm in the heat of battle, I want to be able to listen to a signal, clone it real quick, and then I want it saved to the Raspberry Pi. Super simple. And then I want to be able to recall that and then play it back as many times as I want. So basically, you select the signal you want to transmit, you tap fire, and it'll do 20 rounds a second. Now, the default is about 1 round every half second. So it only takes 3 shots to tag you out. So when you look at that immediately, going at 70 degrees roughly, then another 30 degrees, in horizontal positioning. At 20 rounds a second, I was the juggernaut. There's no way you could stop me even with a standard gun. So this is the user face. Again, very janky. Dark mode by changing the background to black. No bootstrap or anything to make this look pretty. But hey, you know what? It worked. Oh, is that it? I lost the last slide in there. Anyway, so the moral of the story is, what we were able to do with this device is we took it in the next couple of weeks after I had built it with my cousin and I, and now we could clone any gun that we wanted to. But the best part, and this is the one that I did not anticipate, is that I could also clone the healing frequency that was used. And so then what I was able to do is I basically just made it so that my younger cousin was omnipotent. He could not be destroyed. Is that the right word? Omnipotent. He's indestructible, right? All these college students would start trying to tag him out, and he'd just run to the other side of the base, no problem, and would never die because I would always heal him. Anyways, so the moral of this story and the moral of this talk is that hacking is not just to break things. It's not just to destroy things. It's to basically bend things that you want to work the way that you want to work, and to still create, but understand how they work, and to reverse engineer things. Does anybody have any questions? Because I went really fast, but I can talk about a lot of things. Going once, going twice. Oh, way in the back. It already was a complete bloodbath. Like, it was one of those things of like, all right, this isn't fun anymore because, the other thing that I didn't take into account is how IR, reflects off of things, especially when it's super bright. And so it was like literally shooting around walls and stuff. So it was like people would be in their base, and it was like, all right, well, nobody can even play. So like, did I demonstrate that I won? Yes, but at the same time, at what cost? Anybody else? Because Doom is not a game that I ever played. My first first-person shooter was 007. So I should have named it the Golden Gun. It's repainted it gold. Anybody else? Anybody else? Going once, going twice. Sold. Thank you, Drew, for the last question.